All right, I'm going to solve all the 18 problems in preparation for the Unit 3 Celebration of Learning coming up Tuesday. All right. These are all the learning targets. All right, on this first one, we want to identify the transformations. So first, the negative sign here on the outside, that's going to be a reflection over the x-axis, or what we can say is that it's a vertical reflection. So anything on the outside of the parentheses is affecting the y-coordinates. Then this -4 is affecting the x-coordinates because it's inside the parentheses. So this is shifting the graph 4 units to the right. So this is 4 units to the right. And then the +2 at the end there, that's definitely outside the parentheses, and that's affecting the y-coordinates, so then that's 2 units up. Okay, just going to do a little bit of this one. So inside the parentheses, you can tell it has a little negative sign. So that's affecting the x-coordinates. So each of the x-coordinates are just going to be the exact opposite sign. And so these are all going to be opposite. So then -1 and then -2. And what that actually does is it reflects the graph over the y-axis, or we would call it a horizontal reflection. Okay, so horizontal reflection is what that is. And then what's happening to the y-coordinates is you can tell there's a -1 that's outside the parentheses. So that means all the y-coordinates are subtracting 1. So -1 from each of those. So you can tell what these are. 0 and then 7. And then the graph I have on the next slide. So you can just plot those points and you get that graph. All right, now these we want to see, we're comparing, of course, to the parent graph, y equals x cubed. And so if it's vertically stretched by 5, that's affecting the y-coordinates. So we're going to put a little 5 on the outside. It's shifted right, so we're going to do x minus 8, and we're going to make sure we put that cube there. And then it's going to go down 3, so we're going to put a little -3 at the end, because again, that's affecting the y-coordinates. Vertically shrunk by 0.5, so that's affecting the y-coordinates, so that's going to be on the outside, so that is 0.5 out there. It is horizontally reflected, so again, that's when it's inside, that's affecting the x-coordinates, so that's going to be -x and then cubed, and then it's shifted up 4 units, so those are y-coordinates being shifted up, so then that's +4. End behavior, so trying to figure out what's happening way at the ends as x approaches infinity and as x approaches negative infinity. So as x approaches positive infinity, what is happening to the y-coordinates? You can tell as we move to the right, we can tell the y-coordinates are getting bigger and bigger, so we're going to say y is approaching infinity. On the other hand, as x approaches negative infinity, we can see that the graph is actually getting smaller, so the y values are getting much smaller. We say they're approaching negative infinity. Oh, and the zeros. So number of zeros, so it has 3 zeros. It's just how many times it crosses how many times it intercepts, I should say, the x-axis. Okay. All right, this next one is really obviously plugging all that into your calculator. So that's going to be, something you're going to have to be comfortable with, and then calculating the max and the min. So when you do that, it kind of looks like, just kind of roughly looks like this. Okay. And you can see the maximum is calculated. I have calculated as -1 or -1.09. and then 5.05. And then the minimum I have calculated right there. And then the zeros are exactly where it crosses the x-axis at those spots. And then where it's increasing is from negative infinity, so that's starting way here negatively, so negative infinity all the way until it gets right there. And what we do is we look at the x-coordinate of the maximum. That's where we get that other endpoint of the interval. And then it's also increasing right here from there to there. And so we use that same x-coordinate. That's the x-coordinate of the minimum. So that's 0.76 all the way to positive infinity. That's where that's coming from. And then it's decreasing just this little interval in between. And that's going to be in between, the negative 1.09 and then the 0.76. So again, just that little area in the middle is where the y values are getting smaller, and so it's decreasing. Okay, if you want to sketch a graph that has those zeros, then you just make yourself a little graph. Of course, you'll have the graph on the slab, but make yourself a little graph, and then the zeros are just right where it intercepts the x-axis. So 0, and then 1, 2, 3, 4, 5. And then you just draw a nice smooth curve that actually goes through each of those zeros. So that's an example of a curve. There are many, different curves you can draw, but they should flow through those 3 zeros. It shouldn't bounce off of the zeros. There shouldn't be any of them that actually hit and then come down like this, because then that would have a multiplicity of 2. It would have an even multiplicity. So it definitely doesn't bounce off of the zeros. Now this one, we're just going to have to combine like terms. So if we have a minus sign, we're just going to make sure that we distribute all of the negative signs to the right of the parentheses there. So I'm going to just rewrite these. And then after I rewrite these with the correct signs, then I'll combine all the like terms. All right, so we also want to write it in standard form, so we're going to look for the highest power we can find. So it looks like this one, so that's going to be negative 2x to the 4th. The next one, I'm going to look for some cubes. So I have 3x cubed and 13x cubed, so that's going to be 16x cubed. Then I'm going to start looking for some squared. So I have 5x squared, I have a 1x squared, so that makes 6. Then I'm going to look for some x's. So I have 8x minus x, so that makes 7x. And then minus 9x, so that makes minus 2x. Then I'm looking for numbers, so I have minus 5 and then plus 11, so that makes a positive 6. So that would be our final answer. Okay, next we're going to do some multiplying, so we're going to have to rewrite this. So we're going to multiply the, or at least the way I'm going to do it, is I'm going to multiply the x plus 3 times the x plus 3. So I'm just going to distribute this x. So it's going to be x squared plus 3x. Then I'm going to distribute this 3. So that's going to be 3x plus 9. And then I'm still bringing this x down. And then I'm going to combine these like terms. So that's going to be x squared plus, when you add those, that's going to be 6x plus 9. And now we still need to distribute, the x. So it's going to be x cubed plus 6x squared plus 9x. So that's our best answer there. Okay, now we're going to do more multiplying, just a lot of distributing. So each one of these terms gets multiplied by every one of these terms. And I'm going to write mine in sort of a vertical format to combine the like terms easier. Okay. Remember when you're multiplying these that you add your exponents. You multiply the numbers like normal, but then you add the exponents. So 5 times 2, so that's 10. And then we add those exponents, so that's x cubed. And then minus 35, and that's going to be x squared. And the next term is minus 15x. That's 5x times a negative 3. The next one I'm distributing is the 2. So now the 2 is getting multiplied by each of those. So the first one's going to be 4x squared. I'm going to put it directly underneath the other x squareds. Then 2 times negative 7x, so that's minus 14x. And then 2 times the negative 3, so that's minus 6. Put a big old bar there and start combining your like terms. So 4x to the 4th, it's going to be minus 4x cubed. Let's see, this one should be minus 41 plus 4, so minus 37x squared. And then these add together, so that's going to be minus 29x, and then minus 6. Okay, what we have here is a difference of two perfect squares. So just do the square root of each of these. So we're going to have, this one's going to be x squared and x squared. The square root of 2401 is 49, so it's just a pattern. So minus and plus. And then we can't break down x squared plus 49, but we can break down the difference of two squares again. So this one breaks down a little further. So x minus 7, x plus 7, and then we bring down the x squared plus 49, and then that's our best answer. All right, now we have a difference of two perfect cubes. So we have x cubed and then minus, and we have to break down the 64 to figure out what's the cube root of that. So you can, on your calculator, you can do math and you can do the cube root. So what we want to do is we want to do the cube root of 64, and that turns out to be 4. So that's going to be 4 cubed. It's important to do that breakdown first. After you do that, you know that this follows a specific pattern. So first is x minus 4, and then what goes in this next spot is this squared. So that's going to be x squared. And then the sign is opposite. So this is SOAP. So same, that's the same sign. And then opposite, this is the opposite. And then what goes in the next spot is always this times this, so that's 4x. And then we have always positive, which is that last sign. And it's always this term right here squared, so that's 16. So that's the pattern. All right, and same pattern again, so let's do a breakdown. So it's going to be 2x quantity cubed, and then we have to think about, what's the cube root of 27, so that's 3, so 3 cubed. So now that we have it broken down, we can follow the pattern. So it's a binomial and a trinomial. So 2x goes here, 3 goes there, same sign, so plus. Then this one, this first term is 2x, the whole quantity 2x squared, so that's 4x squared. And then the opposite sign, which is a minus sign, 2x times 3, which is 6x, and then always positive, and this number squared, so 9. Okay, this one you want to always take out the GCF. That's always the first step. So GCF, so we take out the 3, and then all of a sudden we notice that it is a difference of two squares. So that means we can break it down a little further. So we can do our little pattern, x minus 3, x plus 3. and that's again coming from the square root of both of those numbers. Okay, whenever you have 4 terms, it's kind of a dead giveaway that you're going to be doing factor by grouping. So the first 2 terms, they have an x squared in common. So you take that out and you try to figure out what goes in the parentheses. So it's going to be x plus 4. Then out of the last 2 terms, you try to figure out what they have in common. So not much, but we could take out a -1. And always peek and look over here and see what this one is. So that one's got to be the same, x plus 4. It does work because you can see that -x minus 4, it does give you the same thing back again. And then whatever's in the parentheses, that's what's going to be first. So that's what you're taking out. And then when you do take out an x plus 4, there's this x squared left over from that term, and then a -1 from the other term. And then sometimes that's all you can do, but in this case, this is a difference of 2 perfect squares, so you can break this one down a little further. So x minus 1, x plus 1, and then of course bring down your x plus 4. So everything in the red is the completely factored version. And of course, if you did want to check it and multiply it all back together again, you would get this same polynomial. Okay, this one should be really quick and easy. It's already in factored form, so you just want to figure out the zeros. So what you're doing is you're just taking each of these little factors. For example, the little x minus 7, you set that equal to 0, and then solve for x. So x equals 7. Do the same thing with the little x plus 4. You set that equal to 0. You get x equals -4. Same with the x minus 5. Set that equal to 0. You get x equals 5. Just, obviously solving for x. So your zeros are 7, -4, and 5. So you could say x equals for those. And then similarly for this one, you get x equals, now the x minus 2, there's 2 of those. And so that means you're going to get an answer of 2 twice. So we say it has a multiplicity. We can abbreviate a multiplicity of 2, meaning it comes up twice, has a solution twice. And then the other one is x equals -3. All right, so a little synthetic division and breakdown. So remember, this is set up as x minus. So we put a little 1 in the box, and then we take out the coefficients. So we got 1, 11, 23, -35. We always bring down the 1. I think we're all pretty good at synthetic division, so bring down the 1. Every time you bring something down, you multiply by what's in the box, so that gives you 1. Then this is where you add, so 11 plus 1, so that's 12. 12 times 1, that's 12. 23 plus 12, that's 35. 35 times 1, that's 35. And then we get a 0 remainder. So then we have this depressed polynomial here represented, and it's always remainder constant, x to the first, x to the second. So that means this polynomial represented is x squared plus 12x plus 35. And then what we want to do is we want to try to rewrite this polynomial in its factored form. So that means we need to do a double bubble here. So we're looking for 2 numbers that multiply to be 35 and add up to be 12. This is where we do our little, our little x. So 35, 12. We eventually come up with 7 and 5. So then you can go right to your double bubble answer. So x plus 5, x plus 7 times x plus 5. And then, since you want to write this in factored form, you want to bring down this factor, and you put it right next to it. And then you can put a little y equals if you want to, and then that would be the factored form of this polynomial. Now the zeros are going to be what we did on the last problem, and that just means that we're going to set each of these little factors equal to 0. So we can do that really without any work. So we can say x equals -7, that's this one. Then we can say this one is -5, and then, it's a little messy. So this one is negative 5, and then this last one is 1. All right. Okay, good on that one. Okay, so this one's just synthetic division. Oh, no, same directions as the last one. So it's set up as x plus 2, so that means we put a minus 2 in the box, and then we take out the numbers, the coefficients. So 3, 10, 4, and negative 8. So bring down the 3. 3 times negative 2, so that's negative 6. Add those together, that's 4. 4 times negative 2, that's negative 8. So negative 4, so give us 8. So we get this depressed polynomial. So this is 3x squared plus 4x minus 4. And this is the harder kind of trinomial. So this is where you actually have to multiply the first number times the last number. So we're looking for two numbers that multiply to be negative 12 and they add up to be 4. So that'll take us a minute. We figure out eventually that that's a 6 and that would be a negative 2. And what we do is we rewrite the middle term using those two numbers, these two numbers here. So we're going to rewrite it. So we're going to have 3x squared plus 6x and then minus 2x and then minus 4. And now we're doing normal factor by grouping. So we look at the first two terms and we say, okay, we can pull out a 3 and an x. And that leaves us with x plus 2. Out of the last two terms, you can take out a negative 2, and then again kind of peek and see that it needs to be x plus 2. So then we got x plus 2. So then they both have an x plus 2, so we take that out, and then we see what's left. We have 3x minus 2 left over. Then remember, since we're trying to write this in factored form, then we just bring this guy down. So we have the x plus 2, and so those three put together are equivalent to this original polynomial. So we could just say y equals that. And so this is our factored form. And then it says find the zeros. So then we just have to take each of these little factors and set them each equal to 0. So the first one we would get negative 2. The second one, probably a good idea to set it equal to 0 and make sure you get it right. So you do 3x minus 2 equals 0. 3x, you add the 2 over, and then divide by 3. So it's going to be 2/3. So x equals 2/3. And then the third one's pretty easy. That one's going to be just negative 2 again. So I guess I could say negative 2 with the multiplicity of 2. Okay. And then the last one is just synthetic division. So it's kind of going backwards a little bit. So negative 2 is what goes in the box. And then take out the coefficients. So negative 2, 5, negative 1, and 2. Bring down your first number and always multiply it by what's in the box. So that's 4. Add those together. That's 9. Negative 2 times 9, that's negative 18. Add those two together. That's negative 19. Negative 19 times negative 2 is 38. So this time we do get a remainder. So the remainder is 40. So we're going to say remainder constant x to the first, x to the second. So this is negative 2x squared plus 9x minus 19 plus, and then whatever the remainder is, we put it as the numerator, and then the denominator is whatever you're dividing by. So since we're dividing by x plus 2, we just put that as the denominator, and this is your final answer. All right, so that is it. Good luck.